So we're going to do the solutions to assessment 1. Before you look at the solutions, make sure you attempt the problems, as it's more helpful to work through them yourself, even if you get stuck. Okay, so the first problem has us writing n files asynchronously, where n can be between 1 and 100. So you always have at least one file, and you won't have more than 99. Okay, so 2 digits. Okay, and then we're going to output n files because we're writing them. So this one has to be asynchronous. Okay, and from the lectures, you should know that if we want to perform several tasks asynchronously, we take our DNS, our asynchronous call, which in this case is fs.write file. Okay, so in this case, this is our asynchronous call. But it could be anything. It could be DNS.requests. It could be zlib.inflates. So you would take that DNS call and you would wrap it in a loop. Okay, so this is in contrast to doing something synchronously, where you wrap it in where you have a recursive call. Okay, so because we're doing tasks asynchronously, we're essentially scheduling these jobs. We're scheduling these write jobs for the operating system to complete as fast as it can, and then when the operating system finishes, it'll let us know. And when JavaScript gets that response back, it'll add the callback to a task queue for further completion. Okay, so the code over here, so we require the FS library to have file systems, and this can be changed to any number between 0 and 100. I'll just leave it at 5 for now. This is where our output files is going to go. Our file is written currently, so we're going to start off with a counter to count how many files that we've written. Typically, when you're doing these types of problems, having a counter available is going to be useful because we want to know when we stop at a certain point. Okay, you don't always need a counter, but it's sort of safe to add one in case you do need it later. Okay, so over here is our asynchronous call, fs.write file. Okay, and essentially when we put a loop inside of here, we're saying to do it n times. Okay, so over here we are doing some string formatting to get our string in the right format. So it has to have a leading 0, it looks like. Okay, so I'd use the pad start with the 0 character, but that's not that important. This is setting up the exact path of where I want to write that file, which is going to be in the current directory, inside a directory output, and then the file name. And then we do fs.write file. The first argument for fs.write file is going to be the path. The second one is the data that we want to write. In this case, it's always just going to be data 1, and then in the next example, it's going to be data 2. The specific data we're writing is not that important for these demos. And then over here, we have the callback. Okay, so this is what's going to be added to the callback queue when the tasks finish. So essentially, well, let's finish this and then I'll go over the sort of mental model. So when this task finish, I'm going to print out the path. So it's going to say that, let's say, file 2 was finished writing. Okay, because we're not guaranteeing order. If we have to write, let's say, file 1, and file 1 is, let's say, 17 terabytes large, and file 2 is like 3 bytes, file 2 is going to finish. File 2 is probably going to finish faster. Okay, and then the operating system will let us know, hey, file 2 is finished writing. Okay, even though, right, because these are done asynchronously, it's done as fast as the operating system can do it. So when that happens, we're going to increase our counter variable, files written plus plus, and when our counter reaches our n, at that point we know we're finished. Okay, so let's go over the mental model real quick. Okay, so over here I have the libuv sort of image again from the lectures. Okay, so what happens is when we run this program, when we start this loop over here, the file name is generated, the path is generated for 0, so it's going to be file 0, 0.txt, and then we're going to get to the asynchronous call. It's going to say fs.write file 0-output.txt. Okay, so it's going to say I need to use the fs library to write this file. Okay, so that's going to go to the bindings, and the binding is going to see that this is a asynchronous call. Okay, so it's going to add that task. It's going to go to libuv and say, hey, can you do fs.write file? I'm going to abbreviate here because I'm completely out of space for file 0. Okay, so I'll abbreviate 0.txt. Okay, and when you finish, here's an after write function for the callback. After write. Okay, so libuv is going to go into IO polling, and it's going to add that task. It's going to use its, it's going to request to the disk to complete this task. But because that was the entire process, we don't actually care about waiting for a reply. We move on to the next step, which is to go back to the top of the loop, increase I to 1, and then do it again. So almost immediately afterwards, we're making another fs.write file request, this time for 1.txt. Okay, and so again, we're going to do this, and then when we do it n times, we finally finish. Okay, so inside of here, libuv has gotten several requests at this point, and it's all going to IO polling. And when these are finished, okay, so as these complete, what's going to happen is those tasks will be added to the event queue. Okay, so the callback, in this case after write, will be added to the event queue. And in total, because I have n files and I made n calls to fs.write file, there'll be 10 of these. I mean, there'll be 5 of these. Okay, because I made that many asynchronous calls, so there will be that many callbacks. Even if I have errors, the error flag will be set up. Okay, but I'll always get that many callbacks executed. So these are put into the event queue, and the order of them I have no control over. Okay, because I don't know which files finish first when it's running asynchronously. Okay, so the only thing I can do is over here, I keep a counter that is shared between all the variables, and it's shared because it's outside of this loop. It's outside this block scope. So they share the same reference to the files written variable. And because they share that, each of these calls, when they come onto the stack, they will skip this last statement except for the last one. Okay, because that's the only case where file written matches n. So initially file written would be 1, 2, 3, 4, and none of those match the n equals 5. But after the very last one, okay, when the last one happens, then finally file written matches 5, and it'll print out the finished. Okay, so that's sort of the mental model of how this works. To run the program, I'm going to run it through here because I know a lot of students were having some issues with VS Code. So I'm going to run it through PowerShell instead. And if you're using a Mac, you can use command line, just because VS Code has been giving us problems, it seems. Okay, so there's the output. In fact, let's delete all these files and run it again just to make sure. Okay, and so these are the files. Don't need to look at them because they're not interesting. Oh, actually, let's go back to the outputs. Okay, so you can see that the order of these in which they're writing 01, 02, 03, 00, 04, 00, 03, 02, they're different every time. So if I keep on running this, that's sort of how you can tell that they're running asynchronously. But you also have to be careful that you do your print statements inside of the callback, because if you do your print statements inside of the loop instead, okay, so we know that these files are being created asynchronously, okay, but we put it inside of this loop over here, because this loop is not part of the asynchronous code, but it's part of the synchronous code. It'll print out 0, and then when it finishes, it'll print out 1, and so on. So this is a very common mistake even if, well, actually that's not the right location, but if it's over here or something, it'll still have that problem where because it's not inside of here, this is asynchronous, but it's printing out as if it was synchronous because this for loop is printing out the wrong information. Okay, so make sure your print statements are inside of your callbacks. So before we move on, we're going to look at what I consider cleaner examples. This one has the drawback in that we have a inline function. So this function is right inside of our existing code. It's a bit messy. This second version uses a function inside of a function, which I think is slightly better. Okay, so over here we have that same for loop. We call a write file function over here, so we're going to call this 5 times. And then from inside of here, we use our fs.write file. Okay, and we have our after writes. Okay, so because path and file name were declared inside of this loop, these two variables are scoped to the life of this loop. And when we call write file, the variable path will have a reference to these individual variables. So even though I'm out of the scope of this loop, I can still have access to file name and path. Okay, so we form what we call a closure. Everything else is the same. From here, we can access the only variable that we need is path. Okay, and we sort of passed it in. And so if we run this, it'll give us exactly the same. So this is better. Okay, it's better than the first one because we no longer have an inline function. We do have a new problem that we have this function inside of a function. And I typically don't like that. I would like something more like this. And the problem with this is that we no longer have access to path. Okay, and so to solve that, we introduce a arrow function to preserve any additional variables that we want. Okay, so because the callback over here only gives us a single output error, we are going to wrap it with an arrow function. Okay, you can use the regular function as well. I just like arrow functions in this scenario because these are typically one-liners. Okay, so I'm going to wrap this this function that typically, if I go back, it only contains a single argument error. And if you go into the specification of fs.write file, the argument only gives you a single parameter. And if I want to append extra data to it, this would be how I would do it. So I would take that function, okay, and then I would call a new function which passes in the error and an additional variable path in this case. Okay, and that's how I sort of am able to separate these two functions and pass this variable along forward to the next function. The last version cleans this up a bit. It just notices that why do I have write file over here if all it's doing is calling this function? So I'm just going to move this back into here. And that gives us our final version. Okay, which is, again, the output is identical to the first version, but this one I feel is much cleaner and easier to read because it doesn't have that nesting. For this example, it's fine. We only have one level of nesting, but for examples 3 and 4, you have 4 levels of nesting, and it's better to extract out that data if you can. So let's look at assessment 2, which is this synchronous one. Okay, so the assessment 2 is the synchronous one. And to do synchronous, the example showed us that we should utilize recursion. Okay. So in this one, I've already extracted the two functions out. Typically, when you're doing the recursion, you're gonna have two functions. You're gonna have one for the in this case, you're gonna have one for the process of writing and one for what to do after the writing is completed. Okay, so All right, so we load up our file system library. We input the number of files we want to write. We specify where we're outputting the files to. And then we are going to write the 0 file. Okay, so we're going to write the very first file. So that's going to call the function write, which is going to take a file index. In this case, we're writing the 0 file. And that's going to create a new file name with that index, okay, going from 0 to 99 in this case. Again, this is using the same pad start function that we used previously to generate a file name and then a path. Okay, and then we're going to use fs.writeFile to write to that path, passing in the data. That's going to have a callback. Okay, so in this case, our callback, we're going to use the same technique that we used previously, this arrow function to forward the data ahead, to call a function after write, passing in the error, the path, okay, so the location that we're writing to. And the reason we're doing that is so that we can print it to console, and the file index. And this will allow us to know when to stop. Okay, so we're passing in these 3 variables forward inside this function. So after it finishes writing, then it's going to take the 3 arguments. First, check to see if there's any errors. Then check to see if I'm at the last file, if the current file index is last file index, in which case we're finished. Otherwise, I'm going to print out the file that I just wrote, and then I'm going to call write on file index +1. So I'm going to start writing the next file. Okay, so let's look at this in our conceptual model. I'll write sub-0. Okay, and that is going to call fs.writefile. So it's going to say fs.writefile. Okay. And so libuv is going to get that call, and it's going to go to the IO polling to say, please write file 0. Okay. And then, since that is scheduled, we're finished with this statement, and we move on to the next step. But there's nothing else. This function returns, and then we keep on going down. Here's another function definition, and we're done. Okay, so this program is finished. V8 stack is now empty, and it's just waiting for this IO polling to finish. Okay, so when this eventually finishes, okay, it's going to put a task onto the event queue. It's going to say, okay, I'm going to put, in this case, it's going to say, I'm going to put a function error, and then after write. So it's not putting after write, it's putting the function, the inline function error, which calls after write. Okay, and so because this is now empty, that function moves into V8's stack. Again, the event loop checks to see if V8 is empty, and if it's empty, it'll move this function into there. So this function, error after write, moves into V8 stack. What does this function do? It calls after write. Okay, so that's sort of like the next layer on top of that. And then this progress inside of this function is now going to run. It's going to check to see if the file index is equal to n. It's not. And then it's going to print out the path, and then it's going to write to file index +1. So it's going to do index +1. So it's going to call write on index +1. This is going to add a new asynchronous task to our IO polling for file 2. And then again, we're out of commands. So this pops off, and then IO polling, when it eventually finishes, it's going to add, again, this task back to the event queue. Okay, and this is how we sort of guarantee that file 1 will be written before file 2, because when the next file gets added to the asynchronous call for the next file is not called until we are inside the callback of the first one. So we have this recursive call that inside the after write, we call the write function. Okay, so we write the next file inside the callback of the first one. And then for recursive cases, you need to know when to stop your base case. And our base case in this case is when file index matches number of files. Okay, so let's move on to the third. Well, let's run this. Let's delete all these and then run it. Okay, so no matter how many times I run this, this will always be 0 to 4. Okay, and again, here are all the files, but we don't really care about the contents. It just says data 2. Okay, let's look at, does this one actually have any variants? No variants, okay. So the next one has 3 variants. Let's open these. Okay, so this third one, we start to look at the issues with regard to what we call callback hell, where we have callbacks inside of callbacks inside of callbacks inside of callbacks. Okay, and if we look at this example, it's really, really hard to read. There's so much going on inside of here. So let's just very briefly look at it, and then we'll move on to the second example. So this is going to read the input file. Okay, the encoding is a string. For this course, we'll always use UTF-8 for our strings. And then when it's finished reading, it's going to call the after write function, which splits the string input that we receive back from after read on new line characters. And then it reserves some space. This is actually including the order guaranteed version. Okay, so it reserves some space, and then we loop through each of the records, each of the results. We resolve. So each of the results represents a domain name. Okay, we resolve each of those domains, and then as they finish resolving, we call after resolves on each of these, which increases our count. Again, typically with these types of scenarios, you are going to have some type of counter. And when that counter reaches domains.length, then we're going to combine all the results into a single string and write it. Okay, so you can see that we have tons of nesting, and this is really, really messing. So it's really hard to follow. Let's look at the second example, which is more cleaned up. Okay. And this one is slightly better, at least for me. Okay. So this one I can start from over here. So let's see. So again, we're going to read the input file, domains.txt, and we're going to call the function after read when we finish reading it. Okay. Over here, if we can't read it, we'll print out an error message. We're going to split the data that we read on its new line characters, and we're going to create a empty array, okay, of a predefined length. Okay, this is how we sort of preserve the order, called IP addresses. And then we are going to loop through each of the domains. So we're going to loop through each of the domains and make calls to domain DNS.resolve. Okay, so because we're using a loop over here, this is these are done concurrently. Okay, so these are done asynchronously. You can think of it as almost being done in parallel, but it's going to depend on how many CPUs you have. Okay, but it's going to utilize the resources as efficiently as possible to complete as many of these tests as possible. And when they complete, we're going to get a function. It has 2 parameters, error and record. And then we're going to forward that along with additional data, the index variable, which is a new value every time because this I is considered inside of this loop. And we also have domains and IP addresses. Okay, and these two are going to be the same variables because they are outside of this loop. So after resolution is called once we've finished resolving a domain, and it's going to be called multiple times. It's going to be sharing the same domains and IP addresses. We also have a address resolves over here. I didn't put this. I put this outside because when we have just primitive variables, they're actually passed by value, and it causes problems because these two we can treat them as references, but this one it's going to pass in the value 0 right away, and that causes problems. I'll show you a way to sort of avoid that issue in the third example. Okay, but these two are sort of scoped to after read. So domains and IP addresses are scoped to after read, and there's sort of a shared variable. This I variable, in contrast, will change on each call to dns.resolve. Okay, so we can sort of use that as our index is going to be all the domains, is going to be all the IP addresses. Okay, so as we resolve them, number of addresses resolved is going to be increased by 1. IP addresses sub index is going to be records sub 0. Remember, there's a DNS wrapper for records, so we always have to grab the 0th index to grab the first piece of data. And then if addresses resolved matches domains.length, then at that point we finished reading everything. Otherwise, we still have more things to read. And again, this addresses resolves. Normally, we don't even need this variable. Normally, we can just use IP addresses.length. But because we've specified a bunch of empty slots over here to sort of reserve space for the IP addresses, we need this additional sort of counter variable for how many that we've received, because we can't depend on this array because it's got domains.length as hard coded in. Let's see. So we're going to write, right, once we finish that, we're going to combine everything into a single string. So you don't really need to know about this. For each loop, all it's doing is going to the array. It's appending a tab character to the existing IP addresses, and then attaching the domains information to it. And all of this is sort of being combined into a large output file. You can do the same with just a for loop. And then we're going to use fs.writeFile to write to the output file. It's going to be IP addresses joined with the new line character, and then afterwards we can call after write, which is just a function that doesn't really do anything, just prints out that this has been completed. So let's run this. So in fact, let's go to the second version. Okay. Again, we'll delete that, run it again. Okay, so you can see that over here we have all of our files. We have the IP address as well as the domains separated by a tab character. Right. So the main issue that we had was that I had to have this sort of global address resolves, because if I sort of move it inside of here, this causes problems because when I pass it into, if I pass it into here, this value will always be, in this case, it will always be 0, okay, because it's passed by value every time. So that's actually pretty easy to fix, and we can, in fact, clean up a little bit more of our code. So to fix that, we take that address resolved variable and we wrap it in an object. But if we're wrapping it into an object, we might as well put everything else into an object as well. So over here I have an object domain information. It includes the domains, the IP addresses and the address results. And this cleans up my code a lot because instead of having after result with a bunch of stuff inside of it, I have the variable I, which changes every time, and I have domains information, which doesn't change, which is sort of like my um, global shared space. Okay. So if you want to pass forward a lot of data, consider using sort of an object wrapper in this case. So that inside of here, I can just say domain.address resolve plus plus or domains.ip address. It just keeps everything a bit cleaner. All right, so let's move on to the fourth example. The fourth example is pretty straightforward. We're doing 4 tasks: reading a file, inflating it. The inflated file represents a domain. So we're going to resolve that domain, and then we're going to write the resulting IP address into a file. So this illustrates that it's the nesting level can get out of control. In this example, we actually don't do any error handling because it would be so messy. But if we, again, pull out these functions to make it flatter, we can do error handling pretty much easier. So this is the same code, but it's a flattened version. Okay, so in this case, we will read the file, and then after we're finished reading that file, okay, so this is going to be a binary file. After we're finished reading that file, we'll call the callback after read. Inside of here, we call our error handling function, which just checks to see if the error variable was set, and if so, print it out. And then we'll call the zlib.inflate function to decompress our data. And then after it's been decompressed, we'll call the after decompress function. So this callback, again, we'll call error handling. And it's going to convert our buffer to a string. So decompressed data is represented as binary data. So so it's a buffer data. So we need to apply toString to it to convert it into a usable string, because otherwise it doesn't know how to understand that data. And then once this is finished, we're going to call after resolution. So after that network request has been finished, again, we're going to check to see if there's any errors. And then we're going to take the results and we're going to write it to a file after we sort of strip away the array wrapper. Okay, so this way is much better if you need to expand the code ever. If this is all, if you're not going to do error handling and you're not going to do and you're not going to do any additions to the code, then you could write your code like this, but it's very sort of fragile. If you ever have to come back to this and make changes, it's very painful. Whereas for this, you can sort of extend it if you need to. So let's run this. Okay, so we finished writing our file. Let's open it in VS Code. And so that's the IP address that was resolved. Okay, so let's move on to batch B, which is number 5. So personally, I think this one is the hardest problem. So if you were able to solve this, you should give yourself a pat on the back. So for this one, let's go to the question. So for this one, you need to asynchronously read end files as fast as possible. Okay, so you're going to read files 01 up to 99. Okay, it's going to specify how many files you have to read. And every time you read B files, where B is going to be between 0 and it's going to be at least 1 and less than the number of files. Okay, so every B files that you read, you're going to write the contents of those input files to the next output file. Okay, so for instance, if you have 11 input files and 5 is your B, then you're going to have 11 divided by 5 input files. Okay, so the ceiling of that number. Okay, so so inside of here we have 11 input files and 5 as our batching number. And so we're going to have 3 files, and what's going to happen is, because we're reading these files asynchronously, some are going to come back faster than the others, depending on, let's say, the size. If we have a really big file, it's going to sort of come back last. So we don't care about which files we get back. Okay, we just want to respond back as soon as possible. So we're going to respond back as soon as we get. We're going to start the writing process of our file as soon as we get back, in this case, 5 files finished reading. Okay, so once we finish reading 5 files, okay, we're going to start the writing process. Okay, maybe some of these other files haven't finished reading yet. It doesn't matter. We're going to ask the CPU to start writing, because we can start writing because we finished reading these 5 files. We're going to write this file. So as more data comes in, the rest of these files will be filled up internal memory, but it won't wait for these first 5 files, because we can start the writing process of those 5 files as soon as we finish reading 5 files. Okay, so over here we're sort of trying to minimize our downtime. So the code has us okay, so we are sort of going in between. We have both synchronous and asynchronous tasks in this example. Okay, the asynchronous tasks are that we're trying to read all the files as fast as possible. So we're going to schedule those all at the same time. Okay, so we're going to use a loop for that. Okay, and the synchronous task is that we can't start writing until we've read at least B files. Okay, so we can't start writing, let's say our batch number is 5. We can't start writing the first file until we've read at least 5 files. But we don't want to wait to read all, let's say, 100 files. Because if we have to wait to read all 100 files, then we don't get the efficiency boost, because we finished the first 5 files a long time ago. So we want to start writing that as soon as we can. And again, there might be scenarios. For instance, let's say that this input directory is on the C drive and this output directory is on the D drive or something. Okay, so we have 2 different disks. So even though one disk might be busy reading, the other disk might just be waiting, doing nothing. So if we can optimize that away, it can save us some time. Okay, so over here we generate our path for our file, and then we call a read action, and then when it finishes reading, okay, it's going to take that data that it read. Okay, so it's going to take the data it read and it's going to push it into an array, and it's going to increase the counter of the number of files that it's read by 1. Okay, and again, we don't have any idea of which actual file finished first. If we have, let's say, a bunch of really large files and then 3 small files, those 3 small files will finish first probably. And so we're going to check to see if the files read mod batch files. Okay, so if this equals 0, Okay, so if it's let's see. Right. So every time we read, let's say 5 files, we're going to call the write file function. So what's going to happen is the file's read number is going to go from 1, 2, 3, 4, 5. It's going to call this function, and then it's going to go 6, 7, 8, 9, 10, and it's going to call it again. Okay, every time the modulus, every time mod batch files hits 0. So we start off at 1, and right, we start off at 1, and we increase until we reach n. There's a special case that we've read all the files, but we haven't reached a divisible batch number. In that case, we also call this write file. Okay, so that's the sort of last case. And so inside this write file function, this is generating the file name, so that's not that important. So inside of here, what we need to do is we have an array with partially filled data. Okay, but we know that the amounts that we needed to access, for instance, let's say the first 5 files had finished reading, we know as a guarantee that that data is inside of there. Okay, so conceptually, okay, so we know we have an array, and let's say that this array has 3, 4. Let's say that there's 6 items inside of here in total, okay? And so let's say our b is equal to 3 in this case. So let's say that the first file finishes reading, so we're going to push that data inside of here. The 5th file finishes reading, we're going to push that data inside of here. And the 3rd file finishes reading, okay? So those 3 get pushed into file data, and it fills up this array. When it hits files read mod 3 in this case, it's that we call write files, and write files in this case will print out the first 3 elements inside this array. So even though the rest of these haven't finished yet, we can start pulling data from here. So that's what line 41 does. It slices the array depending on the file number. So we're writing the 0 file. Okay, it's going to start from the 0th index of the array, and it's going to go until the 4th element and stop. But if we're writing the second file, then it starts from index, in this case, 0, 1, 2, 3, and it stops at index right before here, okay, if there were additional files. Okay, so all this is doing is it's creating an array with it's creating a subarray of the data that we know has been read up until this point. Okay, so from here we can do fs.writefile on this data to get it into the output. So let's run this. Again, delete these. And we'll drag these into here. Okay, so here is input 1, input 2, and output 3. And just to prove that it's working, I'm going to change input 7 to be very, very long. Okay, so input 7 is very, very long at this point. And so I'm going to run this again, and because input 7 is very long, hopefully it won't be in the first 2 output files. Okay, so 1, 2, 5, 4, 6, 3, 8, 9, 10, 11. And then the very long file is always going to be sort of last because it takes so long to read it. So this code still has a couple of improvements that could be made. I'd like to decouple this after read function and this after write function. I don't like that they're inside of here. But beyond that, it's pretty much fine. This one I would like to rewrite as a standard function instead of a function expression. But I'll leave the decoupling as an exercise for you. Let's move on to the last assessments. So this one is very similar to 3 and 4. The only difference that you need to be careful with is that first you're working with buffers, and we'll talk more about buffers when we get to sort of buffers and streams. But when we're working with binary data, like compressed data, and we operate on them, it's not information that we can read. Okay, so you can think of binary data as just literally the zeros and ones on a disk. There's no way to tell you need to tell the operating system how to interpret the data. And so in the most common examples, we interpret it as strings. But in this case, this is not data that we can sort of read or write as humans. So we have to work with it in terms of binary data itself. Okay. In addition, when we're working with this example deals with files. And when we're dealing with files, if you change the order of the bits inside of a file, it corrupts the file. Okay, it makes it impossible to read. So the order matters. So you have to go back to the preserving order sample to sort of look at how to solve this one. Okay, so let's go through this one. So we need the file system library and we need the decompression library because we have a bunch of input files. Okay, we have 99 input files. Okay, and we are going to combine these files. Okay, let's see. So each of these files are compressed files. So we need to decompress them individually using the inflate algorithm. And then we are going to, those buffers need to be concatenated. Okay, but again, the issue is that we need to maintain the order. And when we do the inflation process, that's asynchronous. So it may cause us problems if we lose the order. So right away, because order matters, I'm going to create a variable for the reserve space. Okay, because I need to preserve the order. And so I'm going to loop through the files, and I'm going to read each file. Okay, so it goes through each file, read it. The encoding null is important over here because if you don't tell it how to encode data, then it'll interpret it as a string. Okay, so you need to specify encoding null over here when reading data. For writing data, it can figure it out. For reading data, you need to specify the encoding. But again, the two encoding formats that we'll be using in this course are encoding UTF-8 for strings and encoding null for binary data. In this case, the the files that we were given our binary data. Okay, so after we're finished, we call the after read callback, and it's going to give us two parameters, error if there was any errors, and a buffer, which I'm going to call compressed data buffer over here because we have a second buffer that we have to deal with. Okay, so this represents the data that we read, but it's compressed data. Okay, and so we're going to take that compressed data and we're going to pass it through the zlib.inflate function. Okay, and then that's going to have a function after decompress, which is going to give us the binary data buffer that we wanted. Okay, so once we've finished the inflation process, we're going to increase our count for a number of files that we've read, number of files that we've finished processing by 1, and we're going to move the binary data that we read into the reserve space indexed by I. Okay, this is really important. You can't just do something like array.push binary data because then you lose the order. We don't know whether or not which file was inflated first. Okay, so you need to reserve the space. Okay, because we may have a chunk that finishes faster than something else. And so we need to preserve this I. We're saying that this is the I file. Okay, go into the I reserve space. Okay, once all the files have been inflated, where inflated matches files.length, then we can glue together all the binary data using a function buffer.concat. Okay, so this takes an array of buffers and glues them together as soon as one sort of binary chunk finishes. It'll attach it to the next. This will give us a final buffer, and then we know that fs.write file can write buffers. Okay, so we're going to use fs.write file on the output and to create the final file. Okay, so let's run that. Okay, so this creates our file secret.zip, and we can extract it. Okay, and that will show us that it's not corrupt.